Okay, so we have a graph that was constructed, putting a smooth curve through 5 points, 5 given points. We want to estimate the value of x when y equals 6. We want to estimate the value of y when x equals 3. Okay, well, y equals 6. What does it mean for y to equal 6? It means that, well, let's just draw the line y equals 6. Okay, y equals 6 everywhere on this line. Now we want to estimate x when y equals 6. What do we mean by that? We mean we want to find the point or points on the curve for y equals 6. Okay, well, here's a point where y equals 6. And here's a point where y equals 6. Get the x value, we draw the vertical line through this point and estimate where it crosses the x-axis. It's between -5 and -6. It looks to me like it's about -5.3. So I'll label this line here, x equals -5.3. We can see that that's a reasonable estimate. Here's -4, here's -5, here's -6. We could be off by 1/10 more, but and it could, especially since it's a hand-drawn graph, we could be off by more than that. But x equals -5.3 is a reasonable estimate. Over here, here's where y equals 6. Okay. Well, I mean, here's a point where y equals 6. We draw a vertical line through this point. Now, this is a little closer to 9 than 9 is to 8. And if this is the actual width of a unit interval, then we would expect 10 to go here. So this looks like about x equals 9.7 or 9.8. I'll go with 9.8, but I don't have a whole lot of confidence in that. Okay, so our estimates. X equals -5.3. X equals 9.8. Not a very good looking at. These are kind of tough to draw with these charts. It's my excuse when I draw a bad one. Okay. Now let's estimate y when x equals 3. That means estimate the value of y at the graph point where x equals 3. Okay, well, x equals 3 here, so let's draw a dotted line for x equals 3. And here's our point. Now we can draw a horizontal line through this point, and everywhere on the horizontal line, y will have the same value. So when the horizontal line goes through the y-axis, we'll be able to estimate the y value. So not sure how well this is going to work. I'm a little high on the point. Got a bad angle on the board here. That's the second excuse. Okay. Y is approximately, I'm going to say 2.7. Although actually this is a little bit high. I think it's probably more like 2.4 or 2.3 if I had been accurate in going through this point. So my time's a little high. I'm going to stick with the 2.7 estimate anyway. Okay. Because our uncertainties when you do these graphs, that's not an excuse to be sloppy. You want to be as accurate as you can be. And, you know, I think I did pretty well with these other points, but I kind of screwed up that horizontal line. Okay. Is y equals approximately equals 2.7. Okay, really I should say approximately equals. All these equal signs ought to have at least one little wavy line on it. doesn't mean congruent to, but it means approximately equal to in this context. So approximately equal. And both these lines are a little wavy, so it's good that we know that this is an approximation. A better value should be somewhat lower, probably about 2.3. Okay, so it's that simple. Now, one comment I'll make, you can get multiple y values. One thing I didn't do when we constructed this graph is I didn't specify that the graph had to be a function. Okay, a function has to have just one x value for a given y value. And that's the case here, because any line where x equals constant is going to be vertical. And you can see that if you just kind of run a vertical lines across here, there's no point where the vertical line intersects the graph in more than one point. So the function is, or the graph does represent a function. So I'll say the graph represents a function. It's actually one y value for each x. Vertical lines intersect the graph. Does not. Now you want to digest this so that if I give you 5 points, you can sketch a reasonable graph, scale it as we've seen previously, and sketch a reasonable curve and make estimates. That's a fundamental, essential task in this course.